So now that we have plotted these points on the graph, we've created a table of values. The next question that we're going to ask is this a linear relation? Well, first of all, what is a linear relation? Let's see if we can answer this question and define what a linear relation is at the same time. There's actually two ways that we can tell if this is a linear relation between the number of roses and the price. The first way we're going to do it is by looking at the table of values. So we look at these numbers here. Now, we said before that the price is dependent on the number of roses. The more roses you buy, the higher the cost will be. So the price is the dependent variable and the number of roses is independent. Is this relationship linear? Well, what makes it linear? It would be linear if every time we added one rose, the price goes up by the same amount. If that happens, it's a linear relation. If, however, we added one rose each time and the price increase was not the same, it's not linear. So that's what makes it linear. If the y variable, the dependent variable, increases by a constant rate. So let's check to see if that's the case here. Let's first of all look at what happens when we increase the x by 1. So every time here we go from 0 to 1, that's adding 1. We go from 1 to 2, and so on. When we added one rose, our price went up from 0 to $1.50. Okay, so that's the first change. Then, when we went from 1 to 2 roses, we went from $1.50 to $3, so we added $1.50. Then when we added another rose, we added another $1.50. And every time we added a rose, the price went up by $1.50. So here we see that the change from each pair of consecutive y values is 150, 1.5. So that means that it's the same. It's a constant rate of change. And because it's the same, that makes this a linear relation. All right, let's see if we can answer this question by looking at the graph. Now, if you look at the points on the graph, if you were to connect the points, what kind of shape would you get? Would it be a curve, or would it be a straight line? Well, if you look at these points and you connected them, they're all on a straight line going up. Because they're on a straight line, because it's not curving this way or whatever, but it's all straight, it's all on a line, you could connect them with a ruler, then they form a linear relation. Look at the first four letters of linear, L-I-N-E, line. That's what linear means. Basically, a linear relation is a relation that when you graph it, it will make a line. And the reason it makes a line? Because of what we said here. It goes up by a constant rate. So this is 1.5, the distance, the vertical distance between these 2 points. And this is 1.5, and this is 1.5. If it wasn't the same each time, it wouldn't make a line. It would make some kind of curve. It could be curving this way or any kind of shape, but it wouldn't be a straight line. So, to check if a relation is a linear relation, look at the table of values and see if the y values, consecutive y values, increase by the same amount, or look at the graph to see if it forms a line. It can be a line going up, ascending. It could be a line going down, descending, or it could be a flat line, a horizontal line.